Hi, in this video, we're going to be taking a look at cones, which are these shapes down here. Now, cones work very similar to pyramids. So I put an example up here of doing stuff for pyramids. It's a similar formula in that we're finding this lateral area outside of that cone, which is this stuff right here. It uses the slant height L, just as the surface area of a pyramid uses a slant height. And then you've got the area of the base B. Here we're finding the area of our base being a circle, which is pi r squared. Same thing with the volume. We've got that pi r squared, so that's the same as the area of the base. We still got that 1/3, and then we multiply it by the height of the cone, just like we would multiply it by the height of a pyramid. So let's try it out. So if I want to find the surface area and the volume of this cone, the first thing I would need is the slant height from this thing. So L squared has got to equal 3 squared plus 4 squared. So that means L squared equals 3 squared plus 4 squared is 25. So L's got to equal 5. So that is our slant height, L. 4 is going to be the height of that pyramid, or not pyramid, that cone, and 3 is going to be our radius. So when we look for the surface area here, that's going to be pi r L plus pi r squared. So that equals pi our r is 3 and our slant height is 5. And then we're going to use that same r again for our radius over here. So that's just a matter of like simplifying this down. 3 times 5, that's 15 pi plus 3 squared, that's 9 pi. So 15 pi plus 9 pi, our surface area equals 24 pi centimeters squared. To find our volume is 1/3 pi r squared h. So our volume is just going to be 1/3 pi, our radius, and our height. So our radius, we said before, was 3. And then our height is 4, not the slant height, our regular height of the pyramid. So that is 3 squared is 9, divided by 3 is back to 3, times 4. Our volume is 12 pi centimeters cubed. And we're done. That's it. Let's check out one more. So be careful though. When we identify that r, our 9 is going to be our height, just like our 4 was our height over here. This 7, however, is not going to be our radius. The 7 is the diameter. Our radius is going to be half of that, which is 3.5. Then we need to find the slant height of that thing if we've got a height of 9 and a radius of 3. So L squared has got to equal that 9 squared plus 3.5 squared. So L equals 93.25 when I put that in my calculator, but I want to get rid of that squared, so it's going to be the square root of 93.25. And that doesn't turn out very nice, so we're just going to leave it as that 93.25 and a square root. Because then all we got to do is just plug our stuff into our formula right here. So our surface area is going to equal pi times our radius, and then that slant height plus pi radius squared. So our radius is 3.5, so we put that in both of our radius spots. And then for our slant height, we put in the square root of 93.25. Now, this is just not going to look very nice at all, but well, what are you going to do? So we're going to do 3.5 pi square roots of 93.25. At this point, I would almost just like write it as a decimal. 3.5 squared is 12.25 plus 12.25 pi. Our volume, I think, is going to be a little bit nicer because we don't need to use this 93.25. Our volume is going to be 1/3 pi our r squared, which is 3.5 squared, times the height, which is just this 9. So 1/3 of 9 is 3, so we just need to do 3.25 times 3. So our volume is 36.75 pi inches cubed for our volume. And I missed my units on that brown one. It was too messy. It was too messy. I forgot the units. Inches squared. Gross. I would just probably make that more just as a big decimal because it's just so gross. But that one's fine. That one's not too bad. All right. So in this example where we've got a composite figure, we need to break it up into the total equals parts. And I've already kind of marked them a little bit. We've got this cylinder. And then on the bottom, we've got some cone. Something I'm going to need for this thing is I want to identify all of my stuff. So for the cone, this is the height of my cone. I've also got the same radius on both of the things. My radius here is going to be 5. Radius of the cylinder is also going to be 5. The height of the cylinder, though, is going to be 6. What else would I need? I need a slant height for that cone. So if I get the slant height, that's going to be L squared equals our height. So 12 squared plus our radius squared, which is 5 squared. So L squared equals 144 plus 25. L squared equals 169. So that means L equals 13. So we got a nice slant height there. So that's great. As always, I like to just get the volume out of the way because the volume is the easy part when you're doing these composite figures. So our volume is going to be the volume of that cylinder. I know the volume of the cylinder is going to be the area of the base times the height of that cylinder. And then the volume of that cone will be 1/3 the area of the cone's base times the height of the cone. I don't know why I put a b there. It should be pi r squared. But this pi r squared, that's going to be the same b that's going on over there. Well, that's great because they're sharing those bases with each other. So let's figure that out. Let's figure out what b is. So b has got to be pi r squared. So that's pi and our radius squared, so 5 squared. So b has got to be 25 pi. So this b right here, 25 pi. Now this h, be careful about the h's here. This h, the height of this cone is different. The height of the cone is different than the height of the cylinder. Height of the cylinder is 6, but the height of the cone is 12. 1/3. And then this pi r squared, this area is the same as that area, so it'll be the same as that. So the same 25 pi. All right. So our volume just needs to simplify that down. So 25 times 6 is 150 pi. And then let's see, a third of 12, that's 4 times 25. So that's 100 pi. So our volume equals 150 plus 100, so that's 250 pi. All right, now for the annoying part, surface area. So let's see. We know that we want the cylinder, but we don't want this circular cross section that's in the middle. So we need to remove that from the cylinder, and we need to remove that from the cone. So I think I'm going to do it this way. I'm going to do the surface area of the cylinder plus the surface area of the cone. But then I want to remove what I don't need. So I need to remove this circular cross section in the middle. And I need to remove it twice. I need to remove it from the cylinder and I need to remove it from the cone. So minus 2 of those B's. So if I just minus that at the end, I should get the right surface area. Let's try it out that way. And I'm going to jump down here because I think I'm going to need a lot of space for that. So the surface area of a cylinder is 2 pi r squared plus 2 pi RH. The surface area of a cone is pi r squared plus pi RL. And then I need to subtract 2 of the bases, so 2 of the B's. And we already know what that B is. That's 25 pi. So if I just subtract that off at the end, I should be okay. So now I just got to plug in my stuff. So that is 2 pi. Our radius for the cylinder is 5 plus 2 pi. Radius is 5. The height of the cylinder, that's right here. So that's got to be 6. And that's my cylinder in. Then for the cone, we've got pi. The radius of our cone is the same as our cylinder, so that's going to be 5, plus pi, radius again, and then that slant height of 13. Minus 2 of our b's, this circular cross section that's in the middle. I have to subtract it from the surface area of the cone, subtracting it from the surface area of the cylinder. So 25 pi. All right, let's simplify that down, eh? So 2 times 5 squared. 5 squared is 25. That's 50 pi. 2 times 5 is 10. Times 6 is 60 pi. 5 squared, that's 25. So that's plus 25 pi. 5 times 13 is 65. And then 2 times 25 pi should be 50 pi. So minus 50 pi. Oh, so this 50 pi and that 50 pi, those two just kind of go away. So we've got 60 plus 25 plus 65. So that's 85 pi plus 65 pi. So that is 150 pi. So the surface area is 150 pi. Oh, feet squared. Units are important. Feet cubed. And there are our answers. Woohoo! That is it for our video about the surface area and volume of cones. Reminder that the surface area and volume of cones are basically the same thing as the surface area and volume of a pyramid. We're finding the lateral area and then adding on our base, and then we've got a 1/3 the base times the height of our figure. Thank you for watching. Bye bye.